All right. Well, believe it or not, we're already at Module 7, which is our last section for notes. And, there's no easy way to say it, but this one does contain actually a lot of information that we'll have to work through. So let's go ahead and dive in. For 4.1, we're visiting one last type of graph. And sorry, let me not have that bleed through. We're visiting one last type of graph, and these are exponential functions. So let's learn about this parent function. So this parent function is 2 to the x. And notice what I said here is I put parent in quotes. So why am I doing that? And it's because this is the first time that, you know, we've had x in a square root. We've had x in absolute values. We've had x be multiplied to. We've had x's have different powers, and those give them different names. But exponentials are special because now the x is the exponent itself. And so technically you could see that like this, 3 to the x, is still the same type or form of an exponential, but it technically, like, I guess what I'm saying is your parent function here is anything to the x, like one, or not one, it needs to be different than one, but 2 to the x, 3 to the x, 4 to the x, 5 to the x. You could even get into negatives, and weird stuff happens there. We're not going to worry about that in this class. But I guess what I'm saying is each base, as we're going to call them, 2 in this example or 3 in this example, should have the same function, shape to them, and the same general characteristics in a sense, but the precise numbers will vary a little bit. And so that's just something that's kind of special about these. So just bear that in mind. Anyways, let's graph 2 to the x, and let's graph it. And really what we're trying to do here is not solve any question in your homework yet. We're trying to give you an intuition to your homework as we go through. So what do I get if I plug in, you might be wondering why I know to start here, but don't worry. If I plug in 0. If I plug in 0, then that's 2 to the 0. And here's an important thing to remember. Anything to the 0 power is 1. Maybe you remember that from your prior math classes, but that's a super important idea. So I plugged in 0, 2 to the 0 gives me 1. Use a calculator to check that. What if I plug in 1? Well, if I plug in 1, 2 to the first power, hopefully we know that anything to the first power is itself. And then what do I get when I plug in 2? Well, 2 squared, well, the base is 2, and I'm plugging in 2 to get me my squared. So 2 now squared instead will give me 4. And if I plug in 3, then now 2 cubed gives me 8. So let's plot those points and see what that looks like. 0, 1, 1, 2, 2, 4, and 3, 8. And you might be saying to yourself, wow, Mr. Rao, that went off the page very quickly. And well, maybe you've heard that kind of term before. Even though it's a math term, you've probably heard of exponential growth, or wow, this company is exploding exponentially, or whatever. That's where the idea comes from. It comes from it is increasing and at a very, very strong high rate. Also, sorry, I knew there was something wrong here. This should have been 2, 4. I was wondering why the shape didn't look quite right to me. So sorry. 0, 1, 2, 0, 1, 1, 2, 2, 4. Yep. And then 3, 8. It went off the page a little bit. Okay, so this shape is exponential growth, and you already saw me hint at what the answer is, but now we need to learn about what do I get when I plug in -1. And so this concept right here, we didn't formally write it out, but this is super, super important. So catch this. When I plug in -1, I'll actually work this out to the side. 2 to the -1, due to some exponent laws, is equal to 1 over 2 to the first. So what on earth just happened there? Well, we just learned that a negative exponent can transfer to the bottom and become positive. And so now, what's 1 over 2 to the first power? Well, that's just 1/2. And so I get 0.5 or 1/2, however you want to write that. So here we go. At -1, I'm 1/2. Okay, well then what do I get when I plug in -2? Now, honestly, you should stop, pause, think about what that could be, but we'll just, again, trailblaze forward. So if I plug in -2, it would look like this. Due to what I just said, I see a negative exponent, so let's transfer it to the bottom and make it positive. I just got 1/4. And so, even though it doesn't quite look like it, I guess I'm going to write it as 1/4 and not 0.25, but you can see some symmetry here. If I, and honestly, maybe to see better symmetry, let's not write it as 0.5, let's write it as 1/2. And now you'll see the symmetry. I had 1 in the middle, and then it was 2, 4, 8. And look at what's going on the fraction side on the other end. I have 1/2, but 2, 1/4, but 4. So what do you think you get when you plug in -3? You guessed it, 1/8. Now, what does that look like on the graph? It essentially looks like this. And this goes on forever, but here's the main question. What happens as x approaches negative infinity? What happens as we plug in more and more negatives? Do I end up getting negatives? And I'm holding there for a second because hopefully you know the answer. The answer is no, I don't get any negatives because I can see right here, plugging in negatives didn't give me negatives. They just gave me smaller fractions. And so this graph ends up looking like this. Now, in other words, the exponential growth is always happening, but visually for you and me, it takes a while to see it kick in and truly become exponential. So what can we then say about this graph then? Let's talk holistically, and this is where we start diving into your homework, but please, please, please don't miss the negative exponent explanation we just went through. So key features are that, well, the domain is once again negative infinity to infinity. This graph does go left forever, kind of clearly by the arrow. Now it also goes right forever. It's just, think about it, when you plug in 4, 2 to the 4th is 16. So it's growing even faster. So it does go right forever. It's just going up so fast it doesn't look like it's going right anymore, if that makes sense. But in other words, you can always plug in another positive number. You can plug 32 in here, but because exponentials grow so crazy, all right, if I have 2 to the 32, I'm pretty sure I'm going to get overflow already. Or no, I'm not yet, but maybe 2 to the, I don't know, 100th. You can see that's saying that this number has 30 additional decimal place moves to express it. So this is a 31 digit number. That's huge, but it does go right forever. Okay, what's the range? Well, the range for this function, I'm going to write it in general like this. It's either k to infinity or negative infinity to k. Now, you'll know what I mean by that, and what I mean by that is there's this invisible line that we're not going to go past, and that's k. So I kept it hidden from you, but really, in this case, there's a plus k at the end here, just like regular function transformations. And in this case, it was 0, so this graph would be from 0 to infinity would be its range. Now, also, because of this whole I'm never going to cross 0 but get very close to it, we've learned a name for that. That's asymptote behavior. And so every exponential function has a horizontal asymptote. In this case, for this question, it's at y equals 0, or in general, y equals k. So maybe we'll write it like that. We'll say y equals k. And then over here to the side, we'll say in this case it was 0 to infinity, and it was y equals 0. So every exponential is going to have these 3 features. Here's what it was for our 2 to the x with nothing else transformed. Okay, from there, I guess I'm gonna say basic transformations, and I'm gonna leave this blank, and I'm more so gonna say, if I can pull it up, here it is. Remember this page. So everything here is gonna happen again. So reflecting over x or reflecting over y, is the negative outside the thing that makes the function its name? Is it inside the thing that makes the function its name? Was I subtracting directly from x, or was I subtracting or adding after the name of the function? Again, that's where the k is. The k is adding or subtracting after the exponent and on the same level, not up inside the exponent. So all of those function transformations, I guess I'm just leaving that blank there to kind of say you could insert all that same information here. So how do we hopefully try to wrap up this video? Is we're going to look at 6 different graphs that all have the same base. So we're on to this next page. And that's how we're going to review our function transformations and kind of think about our domains and ranges. And I might honestly open up your homework and do a problem or two. Anyways, let's just dive in and do it. So notice first, scrolling through all 6 of these, scrolling or moving your paper, um, they all have a base of 3, as we would call it. So this first graph then is kind of like my quote unquote parent for this page, since they all thankfully have the same base. And so we definitely want to graph this one first. And honestly, we kind of want to look through this page and almost go out of order and ask what's the next like minimal move that happened, and record that to kind of understand the shape. Okay, to save time, I know again that when I plug in 0, I will get 1, no matter what my base is. When I plug in 1, I now get 3 instead. And when I plug in 2, I get 9. So I'm already way off the page. If you remember all the arguments I said before, think about it. If I got 1, 3, and 9, 3 and 9, then on the reverse side, I would get 1/3 and 1/9, and this would continue to shrink and hug 0. So this graph does have a horizontal asymptote. Didn't ask that, but it's important to note. It has horizontal asymptote at 0 because nothing was added or subtracted. And I just want you to understand this behavior, that exponentials start or will usually have like their flat line on the left and increase upward to infinity. And so, well, I guess we are going in numerical order. The next one I want to look at is number 2. Number 2 is 3 to the negative x. And so I'm going to pull up my function transformation list here, and I'm going to say, where is the negative? Is the negative outside of the function, or is it in the thing that gives it its name? So you think about that for a second, and I guess look at 2 and 3 and make your decision. But for this one, for number 2, the negative is happening inside of the thing that gives the function its name. The x is being negated directly, and that's what's going on right here, right? Or in this section. X is being negated directly. There's not a negative out front of my function. And so this means I'm going to reflect over the y-axis, or in other words, I'm going to flip like this. We sometimes call that a horizontal flip, but it's flipping over at the y. And so I now know what this graph looks like. Because of like symmetry, I still have my 0, 1 here, but now the point that goes up to 3 is on the left, and the point that goes up to 9 is on the left, and the 1/3 and 1/9 are on the right. So that negative in the exponent, the negative in the thing that gives the function its name, again, according to this chart, the negative was in the thing that gave the function its name. There wasn't a negative out front of the function. So because, again, the negative is where the function's name is, we get that flipping. Okay, so for the next one then, let's see what we get from here. Now where's the negative? The negative is out front of the thing that gives the function its name. And so in this case, we'll be reflecting over the x-axis. So before I was moving up like this, according to my parent function, flipping would now look like this. So now I've got 0, -1, and I've got 1, -3, and I've got 2, -9, and then I've got my 1/3, 1/9, and so I look like this. Most important thing I want to kind of call out here is that so far all 3 of these, although they look different, they all have a domain of negative infinity to infinity. Now, some of them, because of how they were flipped, now have a different range, but careful, watch this. All of the asymptotes here were at 0 because all of them just flipped in one direction, and so just be cautious of that. Okay, so what then do we do about this next question? This next question is saying, graph the same thing as you had over here, but just move everything down 5. Well, that's actually pretty easy to do. I was at 0, 1, but now I'm going to take that point and move down 1, 2, 3, 4, 5. I was at 1, 3, but now I'm going to go down 1, 2, 3, 4, 5. I was at 2, 9, and now I'm going to go down 5 to 8, 7, 6, 5, 4, 3. And then this one would have been like the 1/3 and the 1/9, and now I look like this. Okay, so the call out I want to make here is that now you have a new horizontal asymptote, and that new horizontal asymptote is y equals -5, because That was the k value that moved this graph up or down. Also, here's the biggest mistake students usually make is when you move down 5, they plot the point at -5, but remember, at 0, 0, this graph isn't actually on 0, 0. At the 0 value, I start at 1. So now at the 0 value, I start at -4 because 1 and -4 are 5 apart. So just cautious of that one little thing there. Okay, 2 more. So what's happening on this graph? Hopefully you can pause and think for a second about what's happening based on those transformations. All right, we're taking our regular points from this graph here on the left. I should zoom out. Give me a second. Sorry, I'll zoom in a second, but it's just easier to zoom out. But now what's going on this graph is this graph has moved right 3, and it's moved up 2. And so I'm going to locate that first point at 0, 1. Here's the original point 0, 1, and I'm now going to move my pencil right 1, 2, 3, and up 2. My next point was at 1, 3, so I go to 1, 3. And from this point, I now move right 1, 2, 3, up 2. Now the next one, I would have, again, been at 2, 9, and I would have moved right 3 and up whatever, but I'm not even going to worry about that. It's just so high up. So now from here, again, just kind of locking in on this behavior, from there, as I move left 1 from this kind of special point, I then just move down to that like 1/3 value above. So now I'm here, and then I've got my 1/9, and so on and so forth. And so again, you can see I've got a new horizontal asymptote. My graph now looks like this. All right, let me zoom back in, which is not fancily, I'm just actually moving the camera. But hopefully you see that's what we did. Here was again the original 0, 1 point. It went right 3 up 2. Here was the 1, 3 point that then moved right 3 up 2. And so the same shape is there, but we do have a new horizontal asymptote. It's at y equals 2. All right, we've got one more for this section. I do want to kind of look at your online homework and show you some of these. Now, watch this. This graph does move down, but that's going to happen after, think about this, we double flip. So, again, think about that parent function that was 0, 1, 1, 3, 1, 9. And instead of moving essentially from flat line to way up and to the right, we're going to take this graph and flip it because of that negative there flips it horizontally. And then we're going to flip it vertically at the same time. And so think about it. If this graph used to open like this and go up to the right, once I flip it, now I look like that. And once I flip it, I now look like this. And so, long story short, with time and practice, you'll learn that this graph would look like this instead because these are the double flips that are present. Oh wait, we're not done yet because now I need to take this graph and move it down by 2. So I guess I'll lightly erase it, but honestly that was kind of a good first step is see how I now have that shadow of that graph. I'm now going to take that graph and here was this point, move it down 2. Here was this point, move it down 2. Here was this point, I guess move it down 2. Move it down 2, move it down 2. There's my correct final graph. Careful, I forgot to do the -2. But notice that the double flip happens first. Now, if you're freaked out right now, let's look at your homework together and show you it's not too bad because thankfully it does a lot of it for you. And let's see that now. All right, bear with me as I window juggle, but you can see essentially we were looking at 2 to the x, and now we have this function. So the first question is what happened? And well, the plus or minus is happening in the name of the thing that gives the function its name. So that's going to be a left-right motion. And remember that your left-right motions are the flip-flop of what you see. So because this says x plus 6, we're actually moving to the left 6. Now they want a graph. And so careful, let's read what it says. It says graph the function and its asymptote. So first thing I'm going to do is draw the graph, and I can click this, and if you hover over it, it'll say exponential tool. So click it, put a dot anywhere. But here's what I want to show you is it gives you all these things. What's your base? The base is 2. Was it vertically stretched or compressed, or horizontally stretched or compressed? In this case, no. And then what did I do? Did I translate it vertically or horizontally? And we said that this graph went left 6. And so you can even just kind of hover over that and see that. Also, did it reflect at all? I'm just checking those. It didn't reflect, but just be cautious of that. So there's my graph, and I'm going to put that away. However, here's the big trick. If I press check answer, it's going to say I'm incorrect. Now, why is that? Well, because the question says to graph the asymptote as well. Now, the asymptote, let me open this up, is a dashed invisible line. So I need to click my dash tool, click my line, and I know that my asymptote is at 0 because there was no plus or minus k at the end. Now I click save. Now I check answer. I get well done. So that's kind of a quirk of this, is that you can't just graph the correct graph. They want the asymptote separately. The asymptote is always a dashed line, and your exponential thankfully gives you a nice little window to just actually type in the transformations rather than carefully plotting points, which is a big convenience. So my asymptote was at 0. That's where I crossed the y-axis. My domain was negative infinity to positive infinity, because it always is for exponentials. And my range, well, because of my asymptote, is I can't be 0, but I'll get very close to it. I'll get very, very small fractions, and then I can go up forever, as this graph does. Cool, so we did that. I think the very last thing to look through is maybe this question, but this one's a hard one to look at online. So let me see if I can toggle my windows. That looks like it works. Okay, this is pretty much where I got what we just did on paper together. So let's go through this really, really quick. So first, which one looks like the basic 3 to the x graph? Now, a basic exponential, so this first one, should end by going up and to the right, and I should definitely have the point 0, 1. And I think the only one that has that is right here at 22. And let me see if it's going to let me hover. Give me a second. Sorry about that. I had to shuffle my windows, but I think now I can grab this and put it there. So great. I have my 3 to the x. Also, I can zoom in on it, and I can see there's my 0, 1. Now I need my 1, 3. There it is. So they've scaled it differently. Careful in your counting, but 0, 1, 1, 3. That's what we did together on the page together. And now we're kind of going to process of elimination. So thankfully, we already did a lot of these in the homework, but which one looks exactly like that graph, but flipped the other way? Which one descends to the left? Or sorry, I guess we'll go in order. Sorry, we'll do this one. Which one would look like this graph, but instead flipped down instead of up? It looks like it could be 21. And in fact, it has to be 21 because that's the only one that actually flipped downward that has the correct shape, just flipped the other direction, going down instead of up. Up next, let's look at this graph. So which graph essentially took this shape and flipped it the other way, which now looks like this, and that looks like 24. Notice how I'm kind of process of eliminating and going out of order a little bit here. Up next, which graph did the double flip? And we already graphed that together, but it did shift down to after. But which one did the double flip? And that one's this graph over here. Again, this takes time and practice, but that's why we did those 6 problems on the graph together. Now, then the final question is which graph moved its horizontal asymptote down to -1, and which graph shifted right 1? And so we only have 2 answers. Let's process of elimination. Every other graph here has an asymptote at 0. And if I zoom in on this graph, if I really zoom in on this graph, I can see this graph's asymptote's now at -1. Well, which equation moves the asymptote? And it's the one where the y value is shifted after the thing that gives the function its name. So this one actually is moving right 1. And so that starting increase is now to the right 1. It used to be 0, 1. Now it's 1, 1. Move to the right 1. Careful how that axis is counting. So this video went a little longer, but good news, bad news. Again, it's the last module, but we're doing a lot of new things here. So stick around and good luck There's only 6 questions in this one, but we had to cover the basics. I'll see you in the next one.